Today I'm going to talk to you about the for loop. Before we looked at the while loop. That's one method we can use for creating loops, which will execute a code block over and over until some determined ending. The for loop is another way, and it's particularly useful when you know in advance how many loops you'd like to perform. The while loop is better first choice when you don't know how many loops in advance you're going to perform. Let's take a look at the for loop. So the for loop has this structure. It is the word for followed by a parenthesis open and some stuff and a close parenthesis and then a code block. The stuff that goes inside the parenthesis is divided up into three sections. You have a pre-step, a keep going step, and a post step. Let's take a look at the picture on the left and see what I mean. The pre-step, which is shown here, corresponds to some type of initialization that you can do before the body of the loop. And the pre-step is given here. The keep going test is evaluated once per loop, and if the evaluation is true, the loop will keep going. So that would be the decision box here and is found here. Then, if the decision evaluates to true, the code block is performed, and after the code block is performed, a post step is done. There's a difference between the pre-step and the post-step in that the pre-step happens just once, but the post-step happens each time the code block is executed. And the post-step is shown here and is given here. Interestingly, and I'll give you an example later on, each of these three, the pre-step, the post-step, and the keep going test, they can all be omitted as long as the separating semicolon is given. In the first example, the integer variable counter is declared first before the for loop. In the pre-step, it's given a value of 0. Then the keep going test is going to end when the value of counter becomes 10. The post step is incrementing the value of counter. So each time through the loop, the value of counter is going up by 1, starts out at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When it gets to 10, it stops. Okay? And that's a consequence of having used less than 10. There are other ways you could have done that. Compare that to the second example, where the integer counter is declared right in the pre-step. Now this is kind of handy in that that variable that is declared right in the pre-step is known only within the context of this for loop. The scope in this case is only inside the for loop. What that means is outside the for loop, the variable counter is not known. In fact, you might have a different variable named counter and it won't conflict. I mentioned before that any of the pre-step, keep going test, or post-step can be empty, but be careful. You need to make sure you know what you're doing. So for instance, the integer counter was declared and initialized before the loop. So therefore, there was really nothing I needed to do here And the for loop can be written with the pre-step blank. If you were to leave the post-step blank, then nothing would take place, be added onto the end of the loop. And if you were to leave the keep going test blank, you'd have to find some other way of exiting the loop. And that hasn't been discussed in class yet, but it will be soon. Now let's take a look at how you can, except for some minor details, a while loop and a for loop is the same thing. So here's code on the left, which declares the counter, integer counter 0 to be a value of 0, and then says while counter is less than 10, and then the code block, but then the programmer had to explicitly put the counter plus plus, the increment of counter, into the code itself, whereas on the right-hand side, the counter plus plus is part of the for loop statement. Okay, so which one should you use? Well, a good rule of thumb, and of course there's always exceptions, a good rule of thumb is if you know in advance how many loops you're going to do, use the for. And if you don't know in advance how many loops you're going to do, you can use the while. I thought it would be a good idea to have an example of a working program. The for loop that you see here is going to have a counter declared right in it, and I'm calling the counter I in this case. Not a great practice, but sue me. The counter is going to go from 0 all the way through 15. So there's going to be 16 total loops executed. Each time through the loop, it's going to print NA. And when the loop terminates, it's going to print Batman. So let's see how to build this. That would be right there, including the specification of C++11, which in this case is not necessary, but for this class it's good form. Dash capital letter W, all says turn on all warnings, and dash G says make the executable compatible with debugging. So I'm building it, it's all good, and let's run it. What do you think you're going to get? Okay, I'll leave it to you to sound that out. Anyway, thanks for watching this on the for loop, and that's the for loop in under 7.5 minutes. Thanks.